The DfMA approach does not necessarily mean that standard or manufactured elements need to be adopted. It may simply mean harnessing design rationalization, materials optimization, just-in-time delivery, or logistics planning to achieve high rates of productivity on site. Becoming more efficient reduces the resources required, such as carbon, materials, cost, or time, whilst also increasing positives such as quality, certainty, and better health and safety. DfMA can also be applied at differing levels of the design process. However, don't take our word for it. Please also get a perspective from the client by viewing the videos.
GSK designs and delivers many projects, and basically the general view is that they don't work very well for us. They take longer than they should, longer than planned. The quality is a struggle to get the levels of quality we want. One of the problems we see is that projects are conceived from a blank sheet of paper. Often they're conceived using sand and cement and steel and pipes, whereas in fact what we want them to be made of are pre-tested components which we can bring together, and the performance is guaranteed, and they come together in a much more reliable way and start up much more quickly and meet our requirements without a lot of time and effort and a lot of waste. So an example of using DfMA was we were looking at how we could deliver facilities into emerging markets at a very high quality, very quickly, and a consistent quality. And we developed a design called Factory in a Box, and basically it was a componentized pharmaceutical facility. We tested it in Kent, and it was built by ex-Gurkha soldiers, so it didn't require specialist labour or specialist trades. It could be built by just competent people, and it was very high quality and very quick, and was cost comparative with local in emerging market building mechanism.
To manufacture. An example of a component could include this bracket. The bracket itself is a simple but essential component which might be used to do the same job in a number of different designs. Mass production gives economies of scale and ensures quality, meaning that when components are designed into a project, their performance is known and can be guaranteed. 2. Subassembly. At the next stage of the process, installing components individually can be a long and laborious process that is significantly affected by the environment in which the task is undertaken. The efficiency of a project can be improved if larger subassemblies like this ventilation distribution subassembly. At the design stage, it is important to design in these pre-made subassemblies to allow this to take place. Subassemblies may be delivered to site ready to fit, in flat pack form, or as a kit of parts. Level 3. Non-volumetric pre-assembly. Subassemblies can be combined to produce aspects of a building's design which might need to be repeated a number of times. Standardized pre-assemblies can be manufactured off-site, delivered when needed, and then installed. From a design perspective, these pre-assemblies need to be designed in from the outset, and also save time in terms of routing pipes, cables, and other services, as much of the hard work has already been done. Pre-assembly